Okay, well, it looks like we're here and people are coming in, so let's go ahead and get started. Let me go ahead and pull up the agenda here to make sure I'm following the procedure here. So intro to, we call it P&P, Pilsners and Programmers. Obviously, for those of us that are on the West Coast, that's a little early to be drinking, but our real developers, the majority of them are all over in Europe. So it's time for them to drink. So if you have your beer, go ahead and grab it. Water's a good choice too. We can go ahead and get started. The idea behind this meeting is that it's an opportunity for our developers to share what they're doing with us internally. And then at once a quarter, we share it with the world, which is what we're doing right now. We give everyone an opportunity to speak up if they have any feedback or opinions on what we're doing, or maybe suggestions that we haven't thought about. We welcome that opportunity to answer those questions and comments. So let's go ahead and get started. First up is Gabor, and I believe he's going to be doing a demonstration of the new features in LINSTOR and the LINBIT graphical interface.
Yes, thank you. So let me share my screen. Okay, yeah, as Brian said, this is the LINBIT graphical interface, which should not contain too much new information in case you are already familiar with LINSTOR itself, but even in a graphical way. So first of all, you see the dashboard. You only see how many nodes you have, resources. As we can see, every resource we have currently has one volume. We have a few error reports, but that's fine because this setup is already up and running for multiple months or even years. I'm not entirely sure. This is, by the way, our live and active internal infrastructure. So yeah, don't expect me to touch anything serious. I'm just clicking around the views and to demonstrate what should be possible in this GUI. This GUI, LINBIT GUI, is available for customers only, by the way, so it's not in the public repositories, in case you're wondering. So yeah, as mentioned, we have internal infrastructure for nodes up and running. We have at every layer property editor in the GUI with the special values or pre-configured what LINSTOR understands, as well as auxiliary properties. So basically everything you would expect from a property editor for LINSTOR. Storage pools are also listable. You see which kind it has, LVM or LVM thin. In this case, I could talk about the snapshot support, why it is not supported on LVM thick, but that's the short version is it's performance reasons. That's why it states here not supported. This is a LINSTOR internal decision more or less, but yeah. Again, every level has basically the same property editor, but with slightly different options to choose from, because not every property is available LINSTOR-wise on every level. Yeah, IP addresses are quite boring, but just to have them shown here. We do have internally a few resource groups for different purposes. HDD to replicas versus, for example, SSD. So those target different storage pools, for example, for the so-called autoplacer within LINSTOR, or have different place counts. We could deploy here actually new resources, which I will not do because of said reasons. Yeah, as we can see, we already have quite a few resource definitions. If I'm not mistaken, it's over 800, spanning over 300 sites of this GUI. Or maybe not entirely. But as you also can see, we almost all the resources are managed by OpenNebula, as is quite visible here. The resources itself might be a little bit more interesting. So we can see that we have some more non-OpenNebula resources here, which are, for good reasons, apparently 4 times replicated, because I assume that this is actually the database this active controller is using, so is based on. So I guess we wanted to make sure to not lose this data whatever happens. But usually setups look like 2 disk full and 1 tiebreaker, 1 diskless resource, and I'm pretty sure that most of our resources look that way. Yes, and again, properties and edit resources. You can edit here, network preferences. But yeah, some of them cannot really be, okay. I'm not sure if this should be modifiable. I'm not aware of this feature, but maybe this is something upcoming which I'm not aware of. I'm not sure. Anyways, basically that's all about it. So almost or the most LINSTOR commands that are available, at least the basic ones that are available on the command line, can be used, not just the viewing commands, but also the creating and modifying commands can be accessed with this GUI. Plus, it gives you a quite nice overview if something is happening or if resources are not really in a good state, so to say. You should get a quite good overview with this LINBIT GUI. And I try to keep this more or less short, so I also end this part of the presentation about the GUI.
Yeah, if someone has a question, you can just ask it now via the chat or raise a hand function and basically ask it openly. Going to give it a 30 seconds and then we move on. Okay.
Yeah, I haven't found the function here. Yeah, it looks pretty cool. But if I understand it well, it is just basic functional. Are you going to implement some physical device management here for creating the storage pools? Because I think it is the most needed feature for the users.
The GUI is certainly still in development. So this is basically the 1.0.1 version, if I'm not mistaken. Yes. So we are quite at the beginning. I assume this is on purpose only the basic functionalities, but I don't have the roadmap on top of my head, but I'm pretty sure that additional commands and functionality will follow.
I see. And will it be published open sourced, or it will be available only for LINBIT customers?
To my understanding, it will stay only for LINBIT customers, but maybe Phil wants to talk about that in more details.
There were some few others GUIs. I'm not sure, LinView maybe. There were some open source projects. Unfortunately, I haven't checked that yet.
Yeah, originally there was, I think, DRBD Management Console, and then that turned into Linux Management Console. And I do think there was a LinView at some point. We've kind of jumped around, but I think we settled on this one. We've got a developer on it that's very, very sharp. So if we get any feedback you have is certainly welcome. I know you've contributed a lot of positive feedback that we've taken to heart and implemented.
Thank you. Thank you.
Any other questions?
Yeah, the raise hand function is, by the way, under the reactions tab.
Got it. Thank you.
Yeah, good. Yeah, Gabor, let's move on.
All right. So the next part of the demonstration is unfortunately on the command line based one, which is the backup shipping feature. This is not really a completely new feature, but since it was not really mentioned in the last community event, we thought that we should give a brief overview how to use it, what it is capable of. So as I said, we have the following setup. we have actually 2 clusters here. So you might want to pay attention to this controllers, which controller I'm sending the requests to, but I will also try to tell you that one. The first cluster is hosted by the LIN1 controller, or the controller running on LIN1, where also a satellite is running and the LIN2 satellite. Whereas the second cluster is almost the same, but with the LIN3 and 4 nodes. So the rest of the setup is pretty much similar to each other. We have 2 actually quite small storage pools, 1 for each node, but 900 megabyte for this demonstration is completely enough. So yeah, there's nothing else to show here. I have no resources, no resource groups or anything else. So let me just paste in a few default commands you might be already aware of. Right now we are creating new volumes with the spawn command. All right, so this is what we right, so we have 2 resources replicated via DRBD. So until now, this should be a quite familiar setup, but in order to backup shipping to be somehow demonstratable, I need to dump in some random data for now, and in a second also some data that we can use to verify. We actually can verify which backup we are going to restore. So this is just for that purpose. And just to demonstrate this is really replicated, now we have written to LIN1, we are reading from LIN2, and this shouldn't be too surprising that DRBD does its job well. So that's our data we would like to create a backup to. All right, and sorry, before I forgot, I should have shown you before. This is the S3 setup, the min.io console, which I just locked myself out. Okay, which has an empty test bucket, but we will come to that later. The point that I wanted to show here that this is completely empty. There's no backups involved here, so a fresh setup more or less. So in order to use backup shipping LINSTOR, we first of all have to set up LINSTOR's encryption mechanism, which is done by this relatively simple command, and I'm prompted to enter any passphrase which I should remember. And the next thing is that we have to tell LINSTOR what the S3 remote is named. So LINSTOR has now a new object called remote. We create an S3 remote, we call it my S3 remote with the URL, the test bucket. This is some S3 specific region which we also have to define. The username we will use, and I'm also prompted a password. This use path style, I can paste you this one. There are 2 different ways in order to communicate with the S3 in general. So this is nothing LINSTOR specific. S3 supports the 2 kinds of communicating with it. And in our example for min.io setups, only support this second way. So this is the reason why I had to use this use path style, because otherwise, I can show you what happens otherwise. If I try to create now a second one without the use path style, LINSTOR actually tries to contact this S3, but it fails because this does not work with our min.io setup, and LINSTOR simply refuses the remote creation. All right, and the fun part is that's basically everything you need to do. So basically these 2 commands, first of all, create a passphrase in general in LINSTOR, and the second is to create an S3 remote. All you have to do now is to actually tell LINSTOR to create a backup, send it to my S3 remote. The backup name should be source, as I created before. And this one is optional. If you don't specify this, LINSTOR will choose by itself from which node the backup should be created. So this should take a second.
But we have one question in the chat.
Oh, sorry.
Yeah, is it the same inscription used for looks?
Yes. Yes, so this is the passphrase LINSTOR basically uses for everything. So this passphrase, an actual key is generated, and that key is encrypted with the passphrase. So it's a bit complicated, but in general, yes, this is the same step you need to do when you want to use LUKS in any setup. All right, so we created the backup. Did I do it wrong? Oh, I'm sorry. I had to actually go into the bucket. So yeah, as we can see, we have now 2 entries here, one of which is 50 megabyte large, which is the amount of data I randomly created, and another .meta file, which is a special file LINSTOR needs to find out which of these actual volumes belong together. And this is basically a LINSTOR internal thing to so-called, we could call it an index file if you want. Where are my notes? There we go. Okay. Right. So we can also list our uploaded backups. And this is what we call a so-called full backup, which means that, as I showed before, we uploaded the full 50 megabytes of backup because, well, we actually needed the whole snapshot, obviously. But if we now make some relatively small changes, basically a few bytes, so one block of change, so to say, and actually create almost the very same command, execute almost the very same command. But in this case, we can also tell that LINSTOR2 should upload the file. This works because even in this case, all satellites who had this resource deployed created a snapshot locally, but only LINSTOR1 uploaded it. That means that in this case, even if this is an incremental backup, we can tell to LINSTOR2 to upload it. So there we go. Now we have 2 data files and 2 meta files, and that is, as we can see, the second data file is much smaller. This is the smallest size apparently an incremental LVM thin snapshot is capable of, because we actually only modified a few bytes, but you can get smaller than that apparently. But the point is, in this demonstration, is that this is an incremental backup, which was shipped to S3. And one thing to mention, LINSTOR also tells you that this incremental backup is based on this full backup in this case. You can also create a second incremental backup and another one and another one, as much as you want. Okay, so it's time to restore this backup. Until now, we were only working on LINSTOR1 cluster. Now it's time to go to LINSTOR3, which I already showed. We have still everything as free capacity, so no resources at all, just to be sure. And again, we need to do a few setup steps. So again, create the passphrase. These 2 passphrases does not have to match, so these 2 clusters can have different passphrases entered here. That does not matter. We also need to create the very same S3 remote description, which I mentioned before. Right. And from now on, even the LIN3 cluster can list the just uploaded backups. So this this list is not based on some cluster local snapshot list, but from actually the min IO. This is also the reason why we needed those meta files in order to build lists like this. So time to restore, as I told before. What we tell is backup restore. Restore the resource called source, this part of the resource, from the given remote to this target. While restoring, we have to specify a target node and a target resource name. Right. Okay, I was too slow, my bad. Because if I would have done that quicker, we could have seen that LINSTOR is actually changing these states regarding if it's still downloading or if it is in the process of restoring or whatnot. And just to demonstrate, we can now read the file, and it is the second change we made. And I know that I said that I'm trying to make this short. I just can't find in my notes the. Oh, right. I'm sorry. There we go. So another point what we can do here now is, instead of just telling LINSTOR to restore a source resource, which LINSTOR will then choose the latest version of that resource. So not just the full backup, but also applying the incremental backup. And if it would be another incremental backup, applying that also, and so on. But in this case, we just want to go back basically to only this full backup without having the incremental backup, which we can do so by setting up a new resource named target part. And we specify that we want to go back to this specific backup. And once that's done, we can read from now the new DRBD device that we are back at the original value of this device. All right.
So we do have some questions.
I'm sorry.
No, it's all right. I didn't want to think we're at a good stopping point, or at least a pausing point.
Mm-hmm.
So one of the questions was, we're using LVM thin and snapshots with LVM. It isn't such a great experience. What is your experience with LVM snapshots and shipping those as S3 backup?
So I assume we are talking about LVM thin and not LVM thick, because those are different topics. I'm not entirely sure what the question is about, because
the question was if backups are supported by the LVM backend, the classic LVM one, not the thinnest.
Gabor, should I jump in
yeah,
here?
Please.
Yeah, so we are relying here on the features of LVM thin, because creating differences between snapshots, only LVM thin can do that. So no, it's not available with the classic LVM.
So you can't create even backup, even the fat one, not the incremental one. Okay.
If I may jump in and speak, because the question was from me. So we are talking about LVM thin, and let's say you have a MySQL data with 100 gigabytes and use an LVM thin snapshot. We sometimes had the experience that negatively impacted the running volume, creating those snapshots. Sometimes we even corrupted the LVM file system. And so we don't have a huge trust into that feature. And my question was, do you have other experiences doing that on a real production database and not just some dummy data. What is your experience with your with this alpha M snapshot feature, and then shipping that to an S3 bucket? That was my actual question.
Let's say I would use LVM thin on a Red Hat system, and maybe not on the Ubuntu distro or on Debian. And if there are any issues with LVM thin, then just give Red Hat the support issue. Apart from that, I can recommend LVM thin up to a size of about 16 terabyte, not beyond, because then it needs to grow the chunk size, and you can only operate it on the smallest chunk size up to, I think, 16 terabyte or maybe 10 terabytes, somewhere in this area. And all this backup stuff also works with CFS. So for bigger volumes than 10 terabytes, I would recommend CFS or ZFS.
Great. Thank you very much, Philip.
Are there other questions I missed? I'm trying to go through the chat.
I may ask you to show snapshot lists in the original cluster.
In the first one, or?
Where you did the backups.
Okay.
Yeah, so every time when you create backup, you create snapshot.
Yes.
Are they automatically removed, or how you can configure the policy for that?
I'm not sure. I mean, it's if it's not implemented already, it's definitely planned. Let's put it that way. I'm not sure if we already did that, but this should be quite a small thing. So
It's
okay,
planned.
sorry?
Right now, backup shipping always creates a new snapshot. It is planned to add the feature that you can ship already existing snapshots.
I don't think that was the question, but rather than
yeah,
if
actually,
we
my
keep
Then I
all
missed the
snapshots.
part.
I just have
Do-
worries that if I have a cluster of the thousands of virtual machines and I enable backup shipping for all of them, so there might be some problem when I want to remove some virtual machine. I probably need to remove all the snapshots first for that. And I think it would be nice if it would do automatically. And also I worry that it would be nice to have some feature to keep up to 3 snapshots, for example, some amount of snapshots for the shippings.
All right, so I was the main developer of the backup shipping feature, and I am currently working on a backup schedule feature, which will basically be a scheduling for backup, so that you can say, I want this resource to ship a backup to this remote every week at that and that time. And while I am not sure whether keep this many snapshots from the regular backup shipping, whether that I will be implementing that, although it does sound very useful. That is definitely a part of the automated backup shipping, of the scheduled backup shipping. So you
Super.
can set,
thank you.
with the automated backup shipping, you can set limits how many snapshots should be kept locally and how many full backups with all incremental backups depending on that should be kept on the remote side.
Got it. And the last question, if you remove resource definition, will it remove snapshots as well?
Not yet.
Okay.
But this is also something that we definitely want to consider, because I understand that this is much more convenient to have it removed with the snapshot with the resource definitions.
in Kubernetes, there is a possibility to create snapshots by a controller and then create new volumes from that snapshot, as far as I know. So when you're creating a new PVC, you can say, create this new volume from this snapshot. Do you also consider implementing that support for that functionality?
I think it is implemented.
It is called LINSTOR snapshot. So usually if you, what's it called? No, I just forget the actual API here. Sorry. Oops. Yes, so if you want to restore a snapshot, you can specify exactly that. So you have to define what the original resource name was, what the original snapshot name is, and what the new resource name should be called. And optionally on what node. If you don't define any nodes here at all, then every node that has this snapshot will restore it into this new volume, volume and resource, obviously. So this is already implemented.
Moritz, do we have that in Piraeus?
Yes, that's already since, I don't know, at least a year ago. So it's
fantastic.
been there
I have
quite
to
a
try
long
it
time.
one more time. Thank you.
All right. Anything else I'm missing in the chat, or? I guess no.
I think you're through the questions.
All right. Okay, so that's great because I'm also almost through the whole backup demonstration. Everything that was actually left was how to clean it up. We have right now 4 different methods in cleaning up. All is self-explanatory. Filter is you can filter it everything that is older than a given time, or delete me all backups from this source origin resource, or everything that this one node was uploading, or any combination of these 3. So you can play around with it. You can also remove just one specific backup ID, which is this one you have to specify there. Or, and this is the most, let's call it dangerous, or S3 key, this deletes the given S3 key unconditionally. So you can use this S3 key to even delete such a meta file, which definitely will corrupt LINSTOR's ability to restore or do anything useful with this snapshot, with this backup anymore. But this S3 key can also be used to delete non-LINSTOR objects from this S3 storage. The other 3 methods only dare to touch LINSTOR created or LINSTOR managed backups. The S3 key is the only one that actually deletes it unconditionally, as I said. But that can also be dangerous. So I think I'm through with the.
Yeah, Andrea, you raised your hand again.
Yeah, sorry, I just wanted to say that I was using Restic for a long time for making backups, even backups of the LINSTOR. And I want to say that I found the options there are quite usable. You can keep backups, for example, 3 weekly backups, 1 monthly, and stuff like that. I would like to see something like that here. If you could implement it, I think it will be really useful.
Yeah.
Just not only the time, I mean that it might be really useful, for example, to keep last 3-day backups and 1 monthly, for example.
Yeah, this sounds like a useful feature. We will definitely put it on our to think list. Let's put it that way.
Yeah, roadmap. It's in the chat. It's in the chat.
All right.
Okay.
Yeah, that's it basically from my side.
All right. Next up, we have Roland. I believe he has some updates on DRBD Reactor for us.
Yeah. Do you hear me?
Yes.
Perfect. Okay. Before I start the demo, I'm not even sure if all in the audience know what DRBD Reactor even is, so I will spend 1 minute quick explanation. It is a daemon that runs on every node in the cluster. and it manages all things related to DRBD events, to DRBD state changes. And it does that by different plugins. So there's, for example, one plugin that exposes DRBD states as a Prometheus endpoint. And there's one plugin where you can define filter rules, and if such a rule matches, you can execute the script. For example, you could send a Slack message whenever a resource becomes primary. Then the main plugin, so to say, is the promoter plugin, which can promote DRBD resources to primary and start user-defined services on top of that. And whenever the node fails, another node in the cluster will take over, will promote the DRBD resource to primary, start the services there. So like a simple cluster manager. The first things Gabor showed you, the LINSTOR database, that's, for example, a perfect candidate for that, to keep the LINSTOR database highly available in your cluster. We use DRBD Reactor internally for that, and we also use it as part of the LINSTOR vSAN. What was missing is some admin feature. So now assume you have your resources, they are started on some cluster node, but now you want to upgrade the DRBD kernel module, or you need to reboot the node. Then obviously you want to move all the DRBD resources to some other node to have them active on another node so that you can do maintenance. And that was possible, but it was more complicated than it needed to be. And that's what I worked on the last week. And let's see if that works. So, do you see a terminal? Me typing?
Yes.
Yes.
Perfect. So that's a simple 3-node cluster. The Alma 8 Linux 25, 24, and 23. So let's jump to the first node. And let's see what we have. We have the Reactor, CTL, status. And we see that we have one promoter resource, and it's active on this node. We also see this in DRBD setup status. It's primary here. And the configuration for that looks like this. So this is basically the most simple promoter configuration you can imagine. It just says, okay, start me a promoter plugin. You can give it an ID, and you say this promoter is responsible for the DRBD resource RCK1 in this case. And it has an empty start service list, so it doesn't start anything. It just promotes the resource to be primary. For the LINSTOR high availability database case, you would add a mount unit so that the file system, the database gets mounted to the file system, and you would add the LINSTOR controller service. And with that, you would be done. Okay, so it's active here. And what you can do now is you can say evict RCK1. So this starts some countdown, does all the things in the background, like masking the target, blah, blah, blah. But what we see now, it said 24 took over. We can see, yeah, 24 is now primary. Then we can go there. If you don't give it a resource, it will evict all resources, which in this case is just this one, and now 25 took over. And that's all fine and nice, but sometimes you don't only want the resource to be on some other node. You also want to block the local node so that it cannot become the host of the resource again. So if you, for example, now the resource is on node 25, but if node 25 now fails, it could happen that the resource will become active on node 24 again. And sometimes you want to avoid that because, yeah, you want to reboot the node or update your DRBD kernel module, something like that. And in that case, it's it's documented in the evict man page. Obviously, you can specify this keep masked flag. So same thing, node 24 took over, but the service is still masked on 25. So we go back to 24 and say keep masked. So only the node 23 could take it over because 25 was already masked. And if we try to evict the resource now, then we will run into a timeout because there's no node left that could take the resource, right? Let's wait for that. So it said, yeah, nobody took over. I will restart it locally. As we see, it's again primary on that node. That operation is always temporal, so the systemd target is masked in /run. So if you reboot the node, if you forget to unmask things or whatever, you did your maintenance, you reboot the node, everything will be fine because that's only stored temporarily in /run. But you can also unmask the resources manually, and I will do that now. Evict unmask. Let's unmask it here, and let's also unmask it here. Switching back to 23, which couldn't move away, couldn't evict the resource. And now it can do that again, and node 25 took over. So all in all, a pretty minor feature, but I think it comes in really handy for when you actually have to use it and when you have to do maintenance work. And that's it.
Okay.
Stop sharing.
Cool. And I think we've up next we've got Moritz with some updates.
Yeah. One question in between. Andre.
Yeah, I just wanted to ask, you're moving targets and there is some systemd units which are dependent on this target. Am I understood it correct?
Almost. So there is one target unit per resource.
Mm-hmm.
And there can be multiple service units, and these services are part of the target. And the target is always the handle for the complete stack. So going back to the case with the LINSTOR database, where we would have the mount unit and the LINSTOR controller service, and this implicit promote the DRBD resource to primary. All of these three would be part of the target.
Got it.
And also the ordering constraints, so that obviously the mount unit has to be started before the LINSTOR controller service. For all of that, DRBD Reactor generates this drop-in files where it defines this ordering between the services. But the only handle it uses is the target.
I see. So there is also some generator for these unit files.
Yeah, it does that in the background from this TOML file we saw from the start list. And from that, it generates tons of systemd magic in the background. Yeah.
That's cool. Looks like DRBD Reactor can actually replace the pacemaker.
Yeah, to some degree, of course. We don't want to replace it in every case. We don't want that. We cannot do that. But in certain scenarios, it can be a replacement, and it already replaced pacemaker in vSAN.
Thank you.
Okay. That answers that question, I guess. Moritz, do you want to go ahead?
Yeah, sure. So actually, we were already talking a bit about Kubernetes, and I'm basically the Kubernetes guy at LINBIT. And so I'll just quickly demonstrate. Can you see a terminal now?
Yes.
Yep.
Great. I just quickly wanted to demonstrate the integration of this backup shipping feature that Gabor already demoed for S3, because we have some special integration with that in Kubernetes. And I've already got my Kubernetes cluster 1 in this window and second Kubernetes cluster in this window. And already got a persistent volume and a pod that's using that volume deployed. You can also see that in the LINSTOR backend. For demonstration purposes, it's just one node. So the first thing you'll want to do is, if we already had support for snapshots in Kubernetes, and that was done using first of all, the volume snapshot class, which is kind of like a storage class. And now we've extended it to also work for S3. And so this is now the snapshot class that you can use to move your snapshots to some S3 storage. And there are lots of different settings you can set. These are basically all the same that Gabor already used when he created the remote object. And there's a special part for the user or access key and secret key, which are hidden here in this, behind this secret, which I won't show you because it's secret. And then there's using this snapshot class, you can create a volume snapshot, which just references the snapshot class and one persistent volume claim. And if I apply this one now, then we can then we can see that the snapshot is already ready to use. And on the LINSTOR side, first of all, a snapshot was created and also a backup for the snapshot. And I've got a few more in here because I was experimenting earlier. But you can see this is the snapshot name, the snapshot we just took right now. And it's already stored here in S3. And then I'll quickly move over. So now we have the snapshot. And now to demonstrate it, I quickly move over to the second cluster. And this one, I want to also demonstrate a few new features. One of them, actually, Andre, is props to you. I want to highlight because thanks to your work, we can now easily generate SSL certificates, both for the communication between LINSTOR controllers and for the REST API of LINSTOR. And previously, this was always a pain, and there was lots of documentation around it. And now you can just set this Helm override here, and then you can just Helm install it with this override, and everything's working. The second thing that I think we can now share with the world is that we've spent a long time working on the a new backend for the LINSTOR database. So originally it was just SQL databases. Then for Kubernetes, we added etcd because everyone in Kubernetes has etcd, but that turned out to be a bit of a pain because not everybody uses etcd, and maintaining etcd is hard. And it's already hard if you have to do it for one etcd instance and for Kubernetes, and then you most likely need another one for LINSTOR, and that was just not really cool. So now we support a Kubernetes backend. So all the LINSTOR information is just stored in custom resources, and there are a lot of them, but I don't know, let's take a look at, it's probably nothing interesting there. There we store information, all the information normally stored in etcd for LINSTOR is now stored directly in the Kubernetes API. So there's no more additional pods or databases you need to run for LINSTOR, so no etcd here. And so what I actually want to demonstrate is restoring from an existing from this S3 snapshot that we did in another cluster, in this cluster.
Before we do that, looks like we do have a question from Andre.
Yeah.
His hand is up.
Oh, sorry, it was, I didn't lower it up, but I have a question, yes. How many requests LINSTOR generates to the storage backend?
You mean to the Kubernetes API?
Yeah, we just have worry that it will overwhelm it with the requests. But if I understood it correct, it generates requests only when you run some operations, isn't it?
Yes, I mean, there are some background tasks that it may run from time to time. I guess you have to ask Gabor that. But there shouldn't be too many requests. It might take a bit of time. It might be a bit slower in the initial load of the database, but most of the data is cached. So there's, yeah.
Thank you.
Yeah.
And then there was the second question with regards to migration from LINSTOR etcd to Kubernetes. I don't want to, there's currently no easy way to do that, but I think Gabor might be working on something in that direction. but maybe I'm promising too much there.
Yeah, it is on my to-do list, but unfortunately, just other things got prioritized higher. So we have it on our roadmap to convert databases, but this is not at the very top of that list, but it will come eventually.
I had some experience migrating from H2 to Postgres, and it was 3 years ago. I wrote a bash script which is just reads all the configuration of the LINSTOR and generates commands to upload the same configuration. And I found that if you have this configuration totally the same, you can just create it on the new database, and it will just continue working with the existing databases, with the existing volumes, with no problems.
Yeah, maybe it's something like that. Anyways, I don't think the plan is to remove the etcd support immediately. I guess I don't know if it ever will be removed, but if we remove it, then we'll make sure to have a migration plan for that. So yeah, what I actually wanted to show you is there's no snapshots here on this cluster, and I also haven't configured any remote, I think. This is sadly one thing you will have to do on your restore cluster manually. So I'll just add my remote right now. And then I can take a look at the backups in here. And this one was the last snapshot we took. So I'll just quickly copy this snapshot name, which is in the Kubernetes world is the handle for everything, everything snapshot related. And now if you want to manually restore such a non-existing snapshot, there's a bit of work involved. You need a volume snapshot content object where you can copy paste your snapshot handle and then apply that. Then there's also the matching snapshot object. This is kind of like persistent volume to persistent volume claim. So apply that one too. And if I configured everything correctly, it already reports that the snapshot is ready to use. But if we take a look at LINSTOR, there's still no snapshot because it just found it in the remote and knows it can download it at any time. But currently, it's not in the cluster. For that, we need some consumer, and there we need to create a persistent volume claim. And in this persistent volume claim, you specify a data source, and this can be a volume snapshot. And this volume snapshot can either be created from the same cluster, or like we did here with the manual steps with the backup. And then apply that persistent volume claim and also some pod that's using it. Something like that. And this may take some time, depending on how fast the restore is. So right now it's creating the volume. And if we take a look now at the LINSTOR state, it downloaded the snapshot, and it should also have a resource right about now. And there's the resource which is using that restores from this snapshot. And now the pod should be running, and I can quickly see that on my mount file there's restored data. For time reasons, I skipped the initial step where I filled that in. But that is the mount data is where this volume is mounted, and it restored just fine. And that's already all I wanted to share. So
that's so cool. Can you just save the original volume snapshot content from the original cluster to make it and just restore it on the second cluster? Is it the same volume snapshot content?
It's almost the same. There
There's
are
just column
some.
handle.
Yeah, so maybe I'll quickly share the screen again, if it lets me. I guess it doesn't let me anymore. Yeah, so basically there's, you need to specify in the snapshot content, you need to copy the status output from the original thing where it specifies the snapshot handle. You need to copy that as the kind of spec input on for the second cluster. There is also, yeah, that's in the spec somewhere on the, and that works. It also works with something like Velero, for example, which is also some kind of scheduled backup solution, which backs up all your YAMLs to S3, and now we can also store the volume itself on S3, and then it will just restore to a completely new cluster.
Can you repeat the solution name?
It's called Velero.
Velero. Got it.
Yeah.
Okay. There no. Looks like it's a clap. I thought Bjorn was raising his hand, but it's. I think it's a clapping emoji.
Yeah.
Phil, I think you're up next.
As the final presenter.
Okay. I mean, we are already over time.
Yeah.
Otherwise, we move it to the next one.
Can also do that.
I'm fine if you want to proceed forward. It seems like we've got people here that are still listening in.
Okay. Then I do my screen share here. Okay, I hope screen sharing is coming through. So I prepared a 3-node DRBD, and what I have been working on is to deal more gracefully with nodes that lost quorum. And that's not yet finished, it's not yet merged, so that this work is definitely work in progress, but I hope to be able to merge it soon. So I have this resource here. It has quorum enabled, and on no quorum policy is set to suspend IO. And so let's maneuver the cluster into something. Yeah, so the only thing I want to show is that on this node, it is this class. So yes, that's more reasonable to show.
Would it be possible to zoom into that terminal alone? It looks like we're getting some overlapping or some fragmentation on the screen.
Yeah, there is some artifact on bottom right terminal. Just switch the tab, I guess, to work.
Then
I'll reshare. Yeah.
I share only this window.
There we go.
I don't know. Okay. Okay. Then let's make a primary here and write something. It really doesn't matter what. And now what I do is from the other terminals, I will show that later, I do a forcefully disconnect from the other nodes. So that means this guy loses quorum.
How do you actually do that?
Okay. Let me switch the terminal.
No, I think you can share full screen. There were just one artifact.
Okay,
Yeah. I think it will work.
Try back full screen. Is it coming through?
Yep, kind of. No, we can see clearly what are you doing, and that's enough.
Okay. So it's this disconnect with force. So that I cannot use the regular disconnect because it, the primary would say, I don't want that you go away. And the disconnect would simply fail with an error code. But with disconnect force, it's, as the name implies, forcefully. So it simply closes the TCP connections and no right to refuse, right? So now it's here diskless and it lost quorum. So that means if I write, this write doesn't terminate. And as DRBD is right now, you are now in a bad position because you have processes in D state. If there was a file system mounted, you will not be able to unmount this file system. So to maneuver this node out of it, you have little options. So we thought that needs to be improved. And the other two guys, so this one still sees this node. So they are 2 out of 3. So they have quorum. So what could happen is that maybe DRBD reactor and promoter promotes this to primary and writes something, right? So now we have kind of a split brain, right? Or not yet split brain. So these two created a new data generation, right? They moved on. And this guy wants to create a new data generation, but it was frozen just before it is able to do so. And now that's new behavior. Now I connect these two partitions. And in that moment, I connected to this one errors out everything. And when this is finished, it will do a forcefully secondary operation. That means it errors out all pending IO requests and expects you that all processes give up the DRBD volume so that you unmount it. And after that, it's secondary again. So that's a graceful behavior, how we can maneuver out of this situation when a node lost quorum. And that will make life a lot easier for our Kubernetes integration when such nodes can be recovered without doing strong operations like rebooting machines. So work in progress.
Okay, you want to go ahead and ask your question, Andre?
Yeah, sorry, I
you can just chime in. You can just chime in whenever you're ready. We know who you are.
In your example, you show DD. What will happen if there will be mounted file system?
It works just the same way. Even if the mounted file system gets IO errors, and if it's a reasonable file system,
unmounted.
It just you will find a line in the syslog where it says, okay, I remounted myself read only because I got an IO error, and the only thing you can do is to unmount it.
Yeah, that's super. And will this behavior enabled by default?
I think we will not enable it by default because it's a behavior change. But as soon as it out, I guess we'll build it into LINSTOR to set it on newer volumes, right? Or maybe in the Kubernetes context. So I'm not sure yet how we.
Any idea how this feature will be called? I just want to keep track on that, and I don't want to lose it. It's very useful.
Yes, it will get a name with force secondary in it. So maybe
Force secondary.
Yes. So maybe on I don't know, on no quorum. Yeah, I don't know yet. Something with force secondary.
Super.
And I also have a clear plan with Moritz how we integrate that into the Kubernetes stuff. So it's coming. We have a plan. Work in progress. That's it.
Yeah,
Okay.
thank you. Oh, lower.
Oh, you got another question?
No.
Okay, well, I think that concludes this one. We've gone a little bit over, so I think we should wrap it up. Thank you all for joining, and I guess we'll see you next time.
Yeah. So as you guys know by now, this meeting is a quarter meeting, so it's always the last Thursday of the month. So roughly in 12 weeks, we will see each other, hopefully again. And in the meantime, you can also join us on the storage days with this time with Red Hat as a partner going into OpenShift, and that is on April 20th. So have a good evening for now, or morning, I guess, whichever time zone you join us here.
Thanks. Goodbye.
Thanks,
Bye.
guys.
Thanks. Bye.